So here we have the normal here we have the normal probability distribution. So for this normal probability distribution, what do we have actually? Can you remember that can you remember that we discussed about the variables, and did I do with you the discrete variables and the continuous variables? එහෙම කියලා?
Yeah.
Okay, for those ones, this normal probability distributions coming under the continuous variables. For example, we have the weight, we have height, or we have, for those kind of ones, we are calling them as continuous variables, and for those ones, we will be calculating, or we will be discussing about the normal probability distributions. So that's all for the normal probability distributions. Now, what it says actually, here for the normal probability distribution, first thing they are going to teach us is about the density curve. Now, what is this density curve? So the density curve represents the distribution of a continuous variable, and it can also be used to approximate the distribution of a discrete variable. Density curve represents the distributions of continuous variable. These density curves will be representing all the continuous variables, the distribution of the continuous variables, and also it can also be used to approximate the distribution of a discrete variable as well. Maybe sometimes, let's assume we have a discrete variable. If we wanted to convert it, or if we wanted to approximate it into a continuous variable, we can use these density curves for those kind of situations. It's not clear for us. Now, what it says, basic properties of density curves. What are the basic properties of these two density curves? The first property will be a density curve is always on or above the horizontal axis. It's always positive. There's no any negative values. We can't have any negative values, or we can't draw the curve. Let's assume we have the coordinates, we have the two axes like this, and this is our x-axis and this is our y-axis now. Okay, we can't have the curve like this. There's no any negative values. It can only be a positive one. I don't know, something like this. But it's always on or above the horizontal axis. And also the total area under a density curve, which is above the horizontals, should always equals to 1. If we calculate the total area of this entire curve, or what we call the under the curve area, then it should always equals to 1. It should always equals to 1. Okay, so for the first one, a density curve is always on or above the horizontal axis. And for the second property, we have the total area under the density curve, total area of this entire curve, which is above the horizontal x-axis, is always equals to 1. Is it clear, those two properties?
Yes.
And for the next one, variables and their density curves, we have for a variable with a density curve, the percentage of all possible observations of the variable that lie within any specified range equals at least approximately and corresponding area under the density curve expressed as a percentage. What does that mean? Now here they are talking about the variables and their density curves. So for these variables and their density curves, for a variable with a density curve, the percentage of all possible observations of a variable that lie within any specified range equals the corresponding area under the curve. For example, it will be like this. Something like this, and again this, and or else maybe something like this. Then the curve would goes as, something like this. So this is the density curve, whatever we have, and the percentage of all possible values. Now, these are the possible values. For example, let's assume we are rolling a dice. So what are the possible values? It can be either 1, 2, 3, 4, 5, 6. Seems like this is an biased dice, because if it's not biased, then all the probabilities should be equal. No? But so I drawn like this. Let's assume that we have a biased one. So biased one means those ones are a little bit, those stems are actually different. And what will happen? The percentage of all possible observations of the variable that lie within any specified range, which equals the corresponding area under the density curve expressed as a percentage. That's what we have. So for example, we can have if it's an unbiased one, now each and every number should be 1/6. The probability of having each and every number should be 1/6. Then how we can draw this curve? It would be all the stems will equal, right? 1/6, 1/6, 1/6, and 1/6. 1, 2, 3, 4, 5, 6. Here we have the all possible values. See, if we add all these curves, if we add the area under the curve, then it will always equals to 1. So here we have 1/6. This is the probability density function. Is it clear?
Yes.
Somewhat okay. Then what does the next part means? Now they have given us the normally distributed variable. So what is normally distributed variable? Normally distributed variable means a variable is said to be a normally distributed variable, or to have a normal distribution if its distribution has the shape of a normal curve. What does that mean? If once we draw the entire distribution, if the distribution has such kind of, if a distribution has such kind of bell-shaped, or else what we call bell-shaped, or else if it has kind of a normally distributed curve now, then that means it is normally distributed. It is normally distributed. That's what we have. Is it clear? So normal distribution means somewhat, is somewhat, again, according to that one, somewhat like that. Okay, that is it. And then what they are talking about, a variable is said to be a normally distributed variable, or to have a normal distribution if its distribution has the shape of a normal curve, or else we called it as another name, that is the bell-shaped curve. This is the bell-shaped curve. So in summary, the normal curve associated with a normal distribution is, it should be a bell-shaped one. It should be centered at the mean. Okay, mean is mu. You can see the graph centered at mu, and also it close to the horizontal axis outside from the range from mu minus 3 sigma. Here the mu means the mu is the mean of the distribution and sigma is the standard deviation. Hurry, once you calculate these values like this, hurry, we can see that the outer layer of the values which we have, which is not within this range, mu minus 3 sigma and mu plus 3 sigma. The whatever the values outside from this range will be close to this horizontal axis. That's the third point. Close to the horizontal axis outside the range from mu minus 3 sigma. Here the mu means mu is the mean of the distribution and sigma is the standard deviation of this entire distribution. This information helps us to sketch a normal distribution very easily. Okay, that is it. Is it clear?
Okay.
Then, heights of female college students. A Midwestern college has an enrollment of 3,264 female students. Records show that the mean height of these students is 64.4 inches and that the standard deviation is 2.4 inches as well. See, I told you that the mean mu is 64.4 and the standard deviation sigma, that is 2.4. We have the normal curve. Normal curve. We should be able to draw like that. So the mean mu value 64.4 coming somewhere around here. See, in the mean. This is a bell-shaped one, or else we would say a curved one. So here 56 or under 57, that is 3, the frequency is 57 or under 58, 6. Likewise, we can calculate the frequencies and also we can calculate the relative frequencies as well. That is 3 over 3,264 and then 6 over 3,264. Likewise, we can calculate the probabilities as well. That's what we did that part in the previous slide for the relative frequencies, or we gave another name that the probabilities of these heights. So we can calculate the probabilities and then we can draw each bars or the histogram Mercator bars and complete with this curve. That's the normal curve. Okay.
Okay.
Examples for normal distributions, whatever we have, height of boys in a class and weight of people. See, these are continuous variables, height, weight, and the marks. Marks also 95.5 and someone can say 90.90 or 90.12. Likewise, it can vary, there's a range. So marks of children in an exam and the blood pressure also, it's also with the decimals and it can be either floating points, floating numbers as well, and the lifetime of a stock of products as well. All these ones are examples for normal distribution. All these ones are examples for normal distributions. And then for the mathematical formula for this normal distribution is, the mathematical formula for this normal distribution is, what was it? This is the mathematical formula for the entire normal distribution. That's what we have. Mean mu is equals to, so if I explain you with the terms, mu is the mean of the normal distribution and sigma squared is the variance. If it's sigma nang, that is the square root of the variance, that is what we call the standard deviation. And n is the number of, n is the, not n, phi is 3.14, that is there, and e is 2.71, 2.71. E means the exponential value, that is E. And this entire one, we call it as a Gaussian distribution. Gaussian distribution. We call it as a Gaussian distribution. Okay,
Okay.
that's the whole part. Then the univariate normal density is completely specified by two parameters. Its mean and its mean mu and variance sigma squared. Univariate, bivariate, එහෙම කියලා තියෙනවානේ. Univariate means, can you remember we defined the variates in earlier tune? Did we discuss or did I discuss? No, right? I didn't discuss it with you, ne? No. Okay. So variate means variate. I'll show you an example for the variate. Variate means actually it's also kind of variables. It's also, again, the value of those variables, we call them as the variate. Value of these variables, we call them as variates. So for the univariate කියලා කියන්නේ එකයි. Uni නේ. Unidirectional. Uni කියලා කියන්නේ always if it's only one. If it's bidirectional, binomial දෙකයි. And for the bivariate, again two. Bi means again two. But uni model, uni language, and unary, so that UNI refers to only a what? Only one. කියලා කියන එකට තමයි ඒක represent කරන්නේ. කියන්නේ එක variable එකක values විතරයි අපිට තියෙන්නේ. හරිද? univariate කියලා කියන්නේ එකයි. Univariates කියලා කියන්නේ variable එකේ තියෙන values. So the univariate normal density is completely specified by two parameters. එහෙම normal distribution එකක්. ඒ කියන්නේ, for example, let's assume we are calculating the height, students' height. එතකොට එක variable එකයි, ඒ variable එකේ values වලට තමයි we normally call them as the variates. එහෙනම් එහෙම තියෙන එකක මෙන්න මේ normal distribution එක, how we gonna define it, that is දැන් මේක ඇවිල්ලා probability density function එකනේ. That is how we read this. P follows a distribution, the normal distribution with mean mu, and the variance is sigma squared. That's how we normally read this expression. හරිද? The univariate normal density is completely specified by two parameters, its mean mu and variance sigma squared. So for simplicity, we often abbreviate previous equations by writing how, that is Px follows a normal distribution with mean mu and sigma squared. To say that x is distributed normally with mean mu and variance is sigma squared. That's what we have. So weight of a student in class A is normally distributed with mean 50 and standard deviation 2.5 කියලා කියන එක. So the variate will be weights. Hari, variate will be all the measured weights. එහෙනම් ඒ weight follows, again, students' weight follows a normal distribution with mean mu. එහෙනම් mu ගේ value එක, that is 50, and the standard deviation 2.5. To find out the variance, variance will be the square root of standard deviation. එහෙනම් you have to calculate the 2.5 ගේ square. 2.5 ගේ square will be 6.25. This is a standard. Is it clear?
Yeah.
Okay. Then the probability using normal curve. How do we calculate the probabilities with the use of these normal curves? So the probability that x lies between A and B is written as how? The probability A is less than or equal to x, and it's less than or equal to b. මෙන්න මේ x කියන region එක A ට equal වෙන්නත් පුළුවන්, A ට වඩා වැඩි වෙන්නත් පුළුවන්, but බීට equal වෙන්නත් පුළුවන් බීට වඩා අඩු වෙන්නත් පුළුවන්. හරිද? එතකොට if we color the range, if we color the correct range of that, that would be probability using normal curve. The probability that x lies between a and b is written as, that is probability of a less than or equal to x less than or equal to b. To find the probability, we need to find the area under the normal curve between a and b. What is the calculation? You have to, if it's a given function, you have to integrate it. If not, somehow we have to find the area of this entire given curve. That area is equals to this relevant probability. That's what they have mentioned here. Okay, now the problems. How do we find areas of a normal curve? Conceptually, we need a table of areas for each normal curves. What will happen? So the question is actually, how do we find areas of a normal curve? To find the areas of a normal curve, either we should have the function. එහෙම function එක තියෙනවා නම් we can do the integration part and find out the values. But if it's not, there should be a proper table of areas which we can find out the normal curve. That's the method. This, of course, is impossible because there are infinitely many different normal curves, one for each choice of mu and sigma as well. So the way out of this is standardizing, which transforms every normal distribution into one particular normal distribution. So the way out of this is standardizing. So to avoid this problem, what we have to do? To avoid this problem, what we have to do? We actually need to convert this normal distribution into a standard normal distribution. එහෙම කළොත් විතරයි we can do the standardizing and avoid this problem. So now how to do the standardization? To do the standardization, here we are going to define a new term. That's what we call the standard normal distribution, which we have the standard normal curve. The same name, both names refers to the same thing, standard normal distribution and the standard normal curve. So a normally distributed variable having earlier you can see that for the previous example also we had mean 50 and the standard deviation or the variance as 6.25, no? But here, always, if it's a standard normal distribution, none, the mean is equals to 0 and the variance is 1. Always, it's an obvious. එතකොට there should be a method to convert this normal distribution into such kind of an what we call the standard normal distribution. That is how to do that. What we have to do, we equate. Now z refers to the standard normal distribution, and how we gonna convert it? That is x minus mu. X means all the relevant terms. X minus mu should divided by sigma. Sigma is the standard deviation. With this equation, we can convert such kind of distribution, normal distribution, into a standard normal distribution with mean 0 and the standard deviation is 1. That's the whole theory part. Is it clear?
Yes.
Okay. So then you can see we can have the normal curves like this. if it's a normal curve now, in the middle we have mu, and the lower limit or a lower range limit will be there, a and b, like this. But if I convert it into the standard normal distribution, in the middle we have the mean is 0, and both the lower limit and the upper limit will be a minus mu divided by sigma, and the upper limit will be b minus mu over sigma, respect to this a and b values. But you should know both the areas are equal in this normal curve as well as this standard normal curve. Both the areas are equal. Hari. Now, then we have the standard normal curve. So in standard normal curve, in the middle, we have the 0, that is the mean. So here for the right side, we have 1, 2, 3, 4 values, the positive values. And for the left-hand side, we have the negative values as -1, -2, -3, likewise. And for the basic properties of the standard normal curve, the basic properties of the standard normal curves will be property 1. So for the property 1, that is the total area under the standard normal curve is 1. The total area under the standard normal curve is 1. And for the property 2, the standard normal curve, anyway, the total area is equals to 1. And for the property 2, we have the standard normal curve extends indefinitely in both directions, approaching but never touching. හරිනේ, මේ දෙන්න ගත්තොත් මේ දෙන්න කවමදාකවත් x axis එක touch කරන්නේ නැහැ, but those ones will be much more closer to 0. And also ඒගොල්ලෝ infinity වෙනකන් යනවා. And for the property 3, the standard normal curve is symmetric. You can see the standard normal curve is symmetric about 0. මේ තියෙන y-axis එකෙන් standard normal curve එක symmetric වෙනවා. That is the part of the curve to the left of the dashed line in figure is the mirror image of the part of the curve to the right of it. And for the property 4, that is almost all the area under the standard normal curve lies in between -3 to +3. Why? The reason is, can you remember, if it was a normal distribution, now in the middle we had mu, and then here it goes mu plus sigma and mu plus 2 sigma, and then again mu plus 2 sigma, likewise, no? I'm saying this. See, mu plus 1, mu plus 2 sigma, mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma. And here mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. What will happen now? If now in standard normal distribution, and in standard normal distribution, mu is 1. Sorry, mu is 0 and the standard normal is 1. හරිද? එතකොට මොකද වෙන්නේ? Here in the middle we have 0. එතකොට 0 plus 1 1, 0 plus 2 2, 0 plus 3 3, and මේ පැත්තට -1 -2 -3. That's how the values are coming. That's how the values are coming. That's why they are telling it as -3 to +3 here. Okay?
Okay.
Then here we can read all these probability values from the distribution table. Give me 1 minute. So here, now we can't always put those things into the table and sorry, put these into the what we call that formula and get the values ni. So there's a the table, data table. We can normal distribution table which we can read the values, probability values from that table itself. So for example, this is only for the standard normal distribution table. Standard normal means with the name itself, it is already standard. It's not changed with the mu or the sigma. That means mu what variance again what it's not changing. So because always the value will be what we call the what we call the so always the mean will be somewhat 0 and the other one sigma will be or else the standard deviation will be always 1. It's a standard for those type of distributions, for those kind of standard normal distribution. We have this data table, probability distribution table to read those probability values, and also we can do the inverse of it as well. අපිට probability එකක් දුන්නාම අර value එක කියවන්නේ හිතන්නකො නිකන් log table එක කියලා log එක දුන්නාම අපි අතුරේ log එක බලනවා ඒ වගේම anti log එකත් අපි බලනවානේ ඒ වගේ තමයි අපිට region එක identify කරගත්තාම probability value එක හොයන්නත් පුළුවන් අනිත් පැත්තට අපිට probability එක දුන්නොත් අතන එන මේ values මොනවද කියලා check කරන්නත් පුළුවන් both ways මේ තමයි එතකොට අපේ තියෙන table එක. So let's see. Now they have given that the Z is අපිට හොයන්න කියලා තියෙනවා probability එක when the standard normal distribution Z is greater than or equal to 1.55. So 1.55 means see the 1.5 Z value එක තමයි අපි read කරන්නේ 1.5. 5 means from this table. See 1.5 ke 5. See. Then the probability value should be 0.4394. That is the value.
Miss, why is it the fifth column?
Sorry?
Why is it the fifth column?
Oh. Ah. හරි 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 ඔන්න. හරි හරි ඔන්න. හරි. Imandi.
Yeah.
You give me like 5 minutes. Can you just give me like 5 minutes?
Okay, Miss.
5 to 10 minutes. Okay. Okay, you are there, right?
Yeah.
Okay. So, your question was why it's 1.55 kirane.
Yeah.
See, now here it is 1.5, no? In here you can see 1.5. So here we have the value for the second decimal place value 0.00, 0.01. දැන් මෙතන value එක අපි read කරන්නේ මෙන්න මේ value එක read වෙන්නේ 1.51. That is for the second decimal place value. මෙතින් second decimal place එකේ value එක තමයි තියෙන්නේ. අර log වගේම තමයි. From the left side you are checking අර 1.0, 1.1 එහෙමනේ අපි left side එකේ කියවලා. For the top you are reading the second next decimal place නේ. The same thing happens here. මෙතන තියෙන 1.5, මෙතන තියෙන 0 එක we are reading the second decimal point value. එතකොට මේ තියෙන්නේ 1.50. 1.50 value එක. Here this value is here this value is 1.51 and this third value is 1.52. See, that's how we are reading this one. Then the last value is 1.55.
Okay.
Hare. So for the first rounded, I mean the whole number and the first decimal place will be coming from this left hand side panel, and for the second half, මෙන්න මෙතනින් උඩින්.
Okay.
How it is. Okay. Then if it's x, I mean z is greater than or equal to 1.55 now, then හරි මේකේ මෙහෙමත් එකක් කියලා දෙන්න තියෙනවානේ. See, now, okay. So then we have to calculate the probability. Calculate the probability of z is greater than or equal to 1.55. If I draw the standard normal curve, in the middle, we have the mu, which is 0. And then 1 now. Here we are marking the z values on the x-axis. එතකොට somewhat here we have 1.55. The area we told and we already learned that the area will be calculating the probability කියලා. See, එහෙනම් this whole area we need to calculate. මෙන්න මේ part එක. Because z is greater than or equal to 1.55. හරිද? එහෙනම් the whole part is 1 නේ. According to those 4 conditions, can you remember that we learned that the entire area is equals to 1 කියලා කිව්වේ මෙන්න මේ slide එකේ තියෙන්නේ. එහෙනම් what will happen here? This entire area is equals to 1. From this mean, it divides into 2 parts. එකක් මේ section එක අනිත් එක මේ section එක. So මේ areas දෙක වෙන්නේ 0.5 and this one also 0.5. හරිද? Now what is happening here is normally මෙන්න මේ what we call මෙන්න මේ distribution එක දෙන්නේ අපිට හරි distribution එක දෙන්නේ probability of is it less than or equal to x විදිහට. ඒ කියන්නේ මේ area එක මොනවාද color කරන්නේ always they are covering this area from the left side. ඔයාලට මම කියන එක තේරෙනවද දන්නේ නැහැ. දැන් මෙහෙම curve එක ඇන්දොත් මේගොල්ලෝ මේ color කරන region එකේ values හැමතිස්සෙම අපිට දෙන්නේ from the left side. It's not from the right side. තේරෙනවද? ඒ කියන්නේ දැන් බිඳුවේ ඉඳන් නම් ඒගොල්ලෝ රීඩ් කරන්නේ මෙන්න මේ left side එකේ ටික තමයි color කරලා මේක දෙන්නේ. හරිද? table එක. So එතකොට අපිට ඕනේ මෙන්න මේ region එක නම් අපි මොකද කරන්න ඕනේ? අපි already දන්නවා මේ total area would be 0.5 කියලා. එහෙනම් මේ 0.5 වලින් අපි මේ රීඩ් කරනවානේ මෙන්න මේ වැලියු එක. මේ වැලියු එක we have to subtract it. ඒ වැලියු එක තමයි අපි මේ ටේබල් එකෙන් රීඩ් කරන්නේ. මතක මේ තියෙන 0.4394. ඔයා මෙතනදී මතක තියාගන්න ඕනේ always from the standard normal curve they give the values normally z is less than x විදිහට. From the left side එකේ ඉඳන් color කරන්න තමයි ඒක අපිට පෙන්වන්නේ. කියන්නේ මෙන්න මේ පැත්තට තමයි color කරන්නේ. එතකොට මේ total area එකේ දැන් හිතන්නකෝ අපිට හදිස්සියෙන්වත් ඕනේ මේ area එක නම් we have to subtract this part, left side part from 1 to find out this one. හැබැයි මේ question එකට මෙතන 0.5 නේ. ඇයි half away they have already given us නේ. එතකොට මේ 0.5 වලින් මෙන්න මේ section එක read කරා මේ section එක subtract කරා නම් we can have the colored region. That's the method. Is it clear? We'll do some questions. එතකොට හරියයි. Okay, first read this one. Mathematics marks for a given assignment has a normal distribution with mean this one and the variance is this one. What is the probability of getting a mark? එතකොට then marks is the univariate. හරිද? Marks follows a normal distribution with mean 500 and here we should have the sigma. Sigma. අබෝ කෙසෙල් කනවා ජෙලි ටිකක් දුන්නා නම් කාවි. ඊට පස්සේ so මෙතන වෙන්නේ දැන් 500 and here the next parameter is what? Is it standard deviation or the variance?
Standard deviation.
Standard deviation. So standard deviation means, hello, standard deviation means the what we call here they have given the variance. Variance ke square root එක. So variance ke square root එක means what is the value? That is 50. එහෙනම් this marks follows a normal distribution with mean 500, with mean 500 and sigma 50. Habai, you can't do the calculations. You can't do the calculation from this. You can't do the calculations from this. Because first you have to convert this distribution into what? A standard normal distribution. To convert a standard normal distribution now, what you have to do? Follows the standard normal distribution, standard normal marks, then it follows what? It follows a normal distribution with mean 0 and with mean 0 and the standard variance is 1. හරිද? Then අපිට ඕනේ මොකක්ද? Originally x means this no. What we want, probability x is getting a marks of 575 or less. That is, we wanted to calculate the probability when x is less than or equal to 575. That is what we want. Habai, we can't calculate this because this is the normal distribution. We have to convert it into a standard normal. එහෙනම් to convert this into standard normal. ඒ කියන්නේ ඒක z වලට convert කරන්න නම් what we have to use? එතකොට probability x minus mu divided by sigma less than or equal to less than or equal to 575 minus mu divided by sigma. 575 minus mu, mu means 500, divided by sigma means 50. Harida. So this left side panel will be, this left side panel will be Z, and Z is less than or equal to, for the right side you can have the value 575 minus 500 divided by 50. Is it clear what I'm doing here?
Miss, can you write that equation again?
Okay. Okay. Anna, tahu kata. Ah. Right. So, let me erase this window first. Now the question is this. Let's assume X. Okay. X means the marks. Alright. So as it is, this marks follows a normal distribution with mean mu. Mu is 500 and the variance is 2500. That means the standard deviation will be 50. That part you already know, no?
Yeah.
According to the given question, mathematics marks for a given assignment has a normal distribution. Marks is X. I'm referring to marks as X. Now, marks follows a normal distribution. 500 with no follows a normal distribution with mean 500 and the standard deviation is 50. Hurry. So now they are asking what is the probability of getting a mark of 575 or more. 575 හරි ඊට වඩා වැඩිපුර හරි ලකුණු ගැනීමේ probability එක. සම්භාවිතාවය. How we write it as a notation? That is probability X greater than probability which is X 575 or less ne. එහෙනම් X less than or equal to 575. Probability of X being less than or equal to 575. මේ part එක තේරුණාද?
Yeah.
Now the question is, we can't calculate these values exactly because this is in normal distribution. We can have the tables to read those values if it's a standard normal one. If it's a standard normal one. But here we have only the normal distribution. What we have to do? We have to convert this normal distribution one into a standard normal one. How? That is X minus mu divided by sigma. For both sides, we are doing the same thing. 575 minus mu divided by sigma. The probability of Z, this whole part will be Z less than or equal to 575 minus 500 divided by 50. Then we already converted into a standard normal distribution.
Okay.
Okay. Then once we simplified it, Z is less than or equal to 75 divided by 50 means actually it would be 1.5. 1.5.
Okay.
So then, probability of z less than or equal to 1.5. Harida.
Okay.
Then once we have this, see now this is less than or equal to less than or equal to you can directly read it from the table. Why? See 1.5 ni 1.5 කියලා කියන්නේ මෙන්න මේක. 1.5 නම් z is less than or equal to 1.5 නම් directly the value would be 0.4332.
Okay.
0.4332. Okay.
Okay.
Can you do the second one? Can you try
Mm.
this?
Okay.
අඬනවද? පුති මැනික අඬනවද? කෝ? Okay. What happened? Try though.
Please can you explain?
Okay, sure. So in this case, IQs are normally distributed with mean 2000 and a standard deviation 30. They have given the one. For this time, I'll use this X as what? X as the IQs. X means IQs. X follows a normal distribution what with mean 2000 and the mu is 30. Uh, Mean is 200 and 30 is the standard deviation. Then they are saying find the probability that a randomly selected person has an IQ between 110 and 120. No? That means find the probability. Probability which this x follows the IQ values ne IQ marks ne mona hari එහෙනම් x okay the capital X should be මොකද කියන්නේ find the probability that a randomly selected person has an IQ between 110 and 120 කියලා කිව්වහම this x should be greater than 110 and less than 120 හරිද this is the probability whatever we wanted to find එහෙනම් again we have to convert it into a standard normal distribution to convert it into a standard normal distribution x minus mu divided by sigma both හොඳේ එතකොට 110 minus mu is again mu means what mu is 200 divided by sigma is 30 for this side we have 120 minus 200 divided by 30. So this will gives us minus 90 over 30 means minus 3, I guess. Minus 3 sigma and here we have 18 minus 18 minus 80 divided by 30 means we might have minus 2 point something, I guess. 2.8 over 3 means 8 over 3 means 2.66666 somewhere around like that. හරිද? Now if we නිකන් ඇඳගන්න curve එක. Curve එක ඇඳගත්තාම හරිද? It's easy for you. In the middle you have 0. හරිද? එතකොට minus 3 should be somewhere around here නේ. minus 3 to මෙන්න මෙතන තියෙනවා minus 2.66. You want this region. හරිද? You want this region. Is it clear? Up to this
Yeah.
point? Okay. Do up to this point. I mean, take a note. I'll clear the window and show you.
Mm. Okay.
Okay. Now what you have to do to find out this region, okay, to find out this region, so you want something like this. මෙතන තියනවා. So you want something like this. මෙතන තියනවා minus 3. මෙතන තියනවා minus 2.66 no. මෙන්න මේ region එක. මේ region එක හොයන්න නම් from that what we call from that table itself what you have to do. So this is where we have 0. එහෙනම් what we have to do first. So first you have to get the total area up until මෙන්න මේක minus 2.66. ඊට පස්සේ we can reduce the area up until minus 3. Then we can have only the requested range. තේරෙනවද? දැන් මං කිව්වේ අර මේක left panel එකෙන් read කරන්න කියලානේ. එතකොට මෙහි ඉඳන් total area එක මං calculate කරනවා -2.66 වෙනකම්. හොඳද? මේ -2.66 වෙනකම් සම්පූර්ණ area එකෙන් මෙතන තියෙනවනේ -3 කියන එක. -3 වෙනකම් total area එක මම subtract කරොත් then the remaining part is ඉතුරු වෙන්නේ අපිට the remaining part is the actual area what we want. Is it clear? The area what we want. හරි. එහෙමනම් එතකොට we can write it as z less than minus 2.66 වලින් we have to subtract z less than probability of z less than minus 3. May values deka you can read it from the table directly itself. These two values you can directly have it from the table. Have මෙතනට තියෙන 1.7 වෙනකම් විතරයිනේ. You should find a ඒ කියන්නේ full table එකක් ගත්තා නම් මෙතන ඇති negative values. Okay. So for the negative values එක්ක එන එකේ then once you read these two where we have those මෙන්න මේ values දෙක read කරලා subtract කරොත් then you can find the actual what we call the probability. Let me show you the wait. I'll show you the standard normal one. Standard normal distribution table. Standard normal distribution table. See my screen. Check whether it's... See the standard normal distribution. මෙන්න මෙහෙම තමයි z එක අර මං කිව්වේ left side එකේ ඉඳන් තමයි ඒගොල්ලෝ measure කරලා තියෙන්නේ කියලා. එතකොට මේ ටික තමයි color කරලා තියෙන්නේ. මේ තියෙන්නේ ඔයාට ඕන z values. එතකොට මැද තියෙන්නේ 0. ඒකත් එක distributions වල එක විදිහයි. සමහර distributions වල තියෙනවා මැද 0 වෙන විදිහට. See මේ තියෙන්නේ 0 ඉඳන් මේ පැත්තට negatives and මේ පැත්තට positives. ගොඩක් වෙලාවට එහෙම තමයි තියෙන්නේ. එහෙම දෙන table එකේ හරි එහෙම දෙන table එකේ you have the whole values like this. මේ තියෙන්නේ negative values. තව කොටසක් තියෙන්න ඕනේ with the positive values. එතකොට ඔයාට ඕනේ -2 නේ -26 right? -26 කරගන්න මේක. එතකොට 0.047 minus මෙන්න මේ මෙතන තියෙනවා 0.013. Then you can easily calculate the probability. Okay, so here, that's why I told you. Then the values would be 2.6 volt at the end, 0.047. You can read that value from here, 0.047 minus 3.0 wala value 0.13 ne. 0.0047 minus 0.0013. That is the value. Again, this subtraction is my final answer. Is it clear?
This in the table that they give for the exam, we don't have the negative
For the
values.
table?
Yeah.
Table, right? You're asking?
Yeah.
Yeah, the table they should give. They should give.
And no, miss, there are no negative values.
Ah, okay. If there are no negative values, sorry. If there are no negative values, then that means, um, okay, if there are no negative
Miss,
values,
I sent you that table.
okay. Okay. Ah, okay. So, okay, let me open it in here. Hmm. Let me stop share and open my WhatsApp and then I'll open it. Now this is what you have, ne? You can hear me well, right?
Yeah.
Okay. So what we have is now they have given us the distribution with the 0 to negative Vanakam, but on this table itself, we don't have that value. හැබැයි එහෙනම් කරන්න තියෙන්නේ, so let's assume like this. Let me expand this first. So with the previous example, if I tell you like this, now anyway, this whole part we will be calculating the what we call the area, no? So then we have if we want somewhere around 3 to minus 3 to minus 2.66 කියලා කියන්නේ, this region is equals to the positive side එකේ තියෙන same region එකට. I don't know whether it's clear for you. 2.66 to 2.66 to 3.00. See the same region එකට equal වෙනවානේ.
Yeah.
Okay. So then both are with the same region. එහෙනම් ඒ same region එක කියලකම now what you can do, you can calculate the 3.0 value. හරි positive 3.0 ගේ value එක read කරනවා from this table. එතකොට මේ whole part එක එනවා. හරි from 0 to 3 වෙනකම් ඒකෙන් 2.66 value එක වෙනකන් ටික calculate කරනවා. කියන්නේ දැන් මෙන්න මේකත් එක්ක හිතා ගන්න. හරිද? මෙතන මැද තියෙනවා 0. එතකොට 0 to 3 කියන total area එක calculate කරලා ඒ area එකෙන් 2.66 වෙනකම් තියෙන region එක subtract කරනවා. Is it clear? So එතකොට 3.0 region එකේ positive value එක වෙන්නේ මෙන්න මේක. ඒ කියන්නේ 0.4987 no. එතනින් we have to subtract 2.66. 2.66 means 2.66 means this, right? 0.4961. හරිද? මෙන්න මේ value එකෙන් මෙන්න මේක subtract කරනවා. එතකොට you can get the middle part. මේ region එක is exactly equals to this region.
Okay.
Just take a note on that.
Okay.
Okay, that is it. Okay, that part is done. Then, that part is done. Then, statistics lesson 14. Okay, so here, if I erase this part, so this is the central limit theorem, the 68.06 rule. Normally, that's what they are saying, that the mu plus sigma, mu and mu minus sigma, and also mu plus 2 sigma, mu minus 2 sigma, the regions. So this whole area is 68.26. This area is 95.44, and this whole part, which covers from mu minus 3r to mu plus 3r. This whole region is 99.74. හරිද? So
Yes.
ඒක තමයි මෙතන කියන්නේ property 1 එකේ මේ region එකේ 68.26 area එක cover කරනවා, and this part is 95.44 cover කරනවා. This with this the third region to third region, that whole part covers 99.74. That's the thing they have given.
Okay.
We call this theory as the central limit theory. Observations lies. Okay. That is the whole part. Any normally distributed variable has the following properties. All possible observations lie within the standard deviation. You can one standard deviation. 95%, 95.44% values will lie in between two standard deviation. You can mu gain the two sigma values. මෙතන 99.74 amount will lie in between mu minus 3 sigma. ඒ කියන්නේ මේ 3 standard deviations දුරින් තමයි මේ whole region එකේ තමයි ඒ ටික. That's what they are saying. Okay.
Okay.
That's the whole part. Then we have the tute as well, right?
Yeah.
Okay. You have already sent me the tute, right?
Yeah. I'll send again.
කවුද අඬන්නේ? Okay, you have already sent me, right? Ah. For the first question, they have given us to find out all the values from the table itself, right? Habai, what we call my advice is first draw the curve and mark the region. හොඳම දේ තමයි අර curve එක ඇඳලා ඒගොල්ලෝ අහන්නේ මොකක්ද කියන region එක ලියා ගන්න. So from that only කියන්නේ මම දැනටත් මම අදටත් I'll also do that. එතකොට you won't lose anything. කියන්නේ you can easily figure out what is the area you need to consider කියලා දැන් මෙහෙම curve එක ඇඳලා if they are asking z is less than or equal to 1.15 and we know in the middle we have 0 somewhere around 1.15 means this no හරිද
Yeah.
එතකොට මේ region එක you can directly take it from the table itself. I have a question though. Probability of z is less than 1.15 කියලා කිව්වම we මං හිතන්නේ we have to take the value from the total, right? Good question. That is according to the table they have given. For the previous one, probability of z less than 1.15 කියලා කිව්වහම yeah, probability of z this amount කියලා කිව්වහම then z is less than 1.15 නේ. That means this whole region no. හරිද? එතකොට whole region වල in the middle we have 0. මේ හරිය තමයි 1.15 තියෙන්නේ. Then the whole part means this part you know that the area is 0.5 කියලා. හරිද? From this region, for this region, you can calculate the value from the table itself නේ. අයි එතනින් එන්නේ මේ region එකනේ. අර ඔයගොල්ලන්ට දීලා තියෙන table එකෙන් බැලුවොත් ඒගොල්ලෝ blue color කරලා තියෙන්නේ from 0 onwards. මං කියන එක තේරෙනවද මන්ද? From 0 onwards නේ. Let me share that. මේ බලන්නකෝ. මේකේ which name it was saved? That is an image, right?
Yeah.
Image එක කොහෙද තියෙන්නේ? මේ තියෙන්නේ. Image එක තියෙන්නේ. Image එක, I think this one. See, here they have marked it from 0. Can you see my screen?
Yeah.
0 to 1 නේ මේගොල්ලෝ මේ color region එක දීලා තියෙන්නේ. එතකොට අර 1.5 වලට වඩා less than area එක කියලා කියන්නේ we should have this whole part. මෙතන ඉඳන්ම ටිකනේ. එතකොට we already know that this part is 0.5. ඒකට මෙන්න මේ table එකෙන් කියවනවානේ අපි value එකක්. ඒ value එක we need to add. හරිද? Is it clear what I'm saying?
Yes.
Okay. Likewise, you can calculate those values, right?
Please can you do?
Yeah. This one, right? For the z is less than or equal to 1.15 කියලා කිව්වහම from the table 1.15 means 1.15 no. If you go through with that 1.15 means the region is 1.15 means 0.3749. Were you able to find out that value? 0.3749. හොයාගන්න බැරිනවද? Let me show you.
Yes.
හොගන් බැරි වුණා, right?
0.3749, yeah.
Yeah, 0.3749. That is
Yeah.
from 0 to 1.15.
Yeah.
මේකට we have to add 0.5. ඇයි the left hand side negative part එකේ area එක?
Yeah.
එතකොට the total probability will be 0.8747. I mean the first question, for this first question.
Okay.
හරිද?
Yeah.
Then for the second question, now again if I draw a curve, again if I draw a curve, now they're asking Z is greater than or equal to minus 27 මොකක් හරිනේ මෙතන තියෙන්නේ 0 somewhere around minus 2.37 is somewhere around here. හරිද? මේකට වඩා වැඩි ටික. Can you see? This whole area තමයි ඒගොල්ලෝ අපෙන් අහන්නේ. I mean area is the probability නේ. Z is greater than or equal to 2.37. So 2.37 is somewhere around here. මේකට වඩා වැඩි ටික. So again this whole part, that is what මගේ screen එක පේනව නේද?
Yeah.
That is 0.5. We only need this region. මෙන්න මේ region එක තමයි අපිට ඕනේ. හරිද? මේ region එක right side එකෙන් region එක read කරන්න අපිට බෑනේ. Because we don't have the negative values නේ. We have only positive values. එහෙනම් මේකටම symmetric region එක කොතනද තියෙන්නේ? 0 to positive 237. එහෙනම් table එකෙන් අපි read කරනවා 0 to 2.37 value එක. 2.37 value එක ගත්තොත් that is 2.37 no. 2.37 value එක ගත්තොත් 2.37 value එක ගත්තොත් that would be either I think 0.4911. 2.37. Is it though? 2.37. 0.4911. I can't find out the negative region area. I can only find out the positive side. Positive one. So, මේකට symmetric කියලා we already learned this zero axis. එතකොට මෙතන තියෙන minus 237 නම් මේ region එක curse එක දිහා බලන්න මේ region එක is exactly equals to this region. Region gives us the probability. එතකොට මේ part එක we can already calculate. මෙන්න මේ ටික. It can directly calculate from the table whatever you have already given. එතකොට එතන තියෙන්නේ 2.37 කියලා කියන්නේ 2.37 කියලා කියන්නේ if you read it that is 0.4911. එහෙනම් මේ 0.4911 කියලා කියන්නේ මෙන්න මේ whole region එක. 0.4911 වලට we have to add what? We have to add this 0.5. That means 0.9911.
It's kind of confusing.
Confusing that. Confusing, right? Okay, we'll do like this. එතකොට ඔයාට කොහොමද මම මේක කියලා දෙන්නේ? මේගොල්ලෝ මේ ස්පීඩ් එකේ උගනලා තියෙන එක තමයි අවුල තියෙන්නේ. What we can do? Okay, we'll do like this. First, we'll come with the step by step. First, I'll ask you to find out. Can you do one thing? Can you, for each and every question, can you don't find the values. Can you draw this normal curve and color the region, whatever we have to find the area? Is it clear what I'm saying?
Yeah.
Don't consider about the values. හරිද? අර x-axis එකේ values mark කරලා just draw all the regions, whatever we need to calculate the area කියලා calculate කරන්නකෝ. මේ draw කරන්නකෝ ඉස්සෙල්ලා.
Okay.
Okay, first පළවෙනි පළවෙනි තුනත් එපා. Okay, we'll do like this. හරිද? දැන් යන්නද ඉන්නේ? හරි. We'll do like this. First only do the less than ones. මේ ඔක්කොම පටලවා ගත්තාම තමයි you can't find out. Hi. එතකොට first one you can do. Okay, and for the F also you can do, for the G also you can do, and yeah, only those ones. Just try these ones. Imandi,
The rest
shall I,
and
yeah, shall I connect with you only those three? Shall I connect with you in another 15 to 30 minutes?
okay.
මම පොඩ්ඩක් එළියට ගිහලා ටක් ගාලා බඩු ටිකක් අරගෙන එන්නම් නේද? අපේ අම්මා බයිනවා මට. හරි, okay. Give me
Okay.
few minutes. I'll quickly go out and come. Okay.
Okay. Okay.
Yeah, yeah. Whoa.